Today's video is using the property of equality and the algebraic method to solve multiplication and division equations. Now, if you haven't already watched the same video series on using the property of equality to solve addition and subtraction equations, I recommend you watch that video first. It's going to give you a more in-depth explanation of using our steps. Understand that we'll be working with one-step equations, which is basically one operation equations, and the steps we'll be following is to isolate the variable by using the inverse operation, using the property of equality to keep both sides equal, and then to check or plug in your answer. Now, it's important for us to realize that in order to follow those steps, we need to know what the multiplication property of equality is, and that would be when you multiply each side of an equation by the same non-zero number, the two sides remain equal. And if we wanted to use the division property of equality, it's very similar. When you divide both sides of an equation by the same non-zero number, the two sides remain equal. But we can put these to the side because we're already familiar with the property of equality, and we kind of simplified it before in whatever you do to one side of the equation, you also have to do to the other, and that's what makes it all balance out. So I would like to use this first example. It's a real-life example of finding the area of a parallelogram to help us to understand how we can apply this concept. So we know from previous instruction that the area of a parallelogram is area equals BH. That stands for area equals base times height. In this problem, we know the area and we know the base. What we don't know is the height. So I have three terms in my expression that I can substitute. My area would be my 72. My base, which is known, is 8. And since I'm multiplying that 8 times x, I'm going to write it as a coefficient. So my equation is 72 equals 8x. Now, to follow these steps, the first thing I want to do is I want that x to be all by itself. Right now, that x is being multiplied by 8. So if I divide 8x by 8, that leaves me with just x. And because I'm going to now use the property of equality, because I divided this side of the equation by 8, I'm going to divide everything on this side of the equation by 8. And 72 divided by 8 does equal 9, and that gives me a solution. 9 is equal to x, or x is equal to 9. Depending on your comfort, you may want to put the x on the left side of your equation. Now, if I want to double check my work, I know area equals base times height, so I'm going to write this out as area, which will be 72, equals base times height, equals 8 times 9, and I know that's true, which verifies that indeed the area, or the height of this parallelogram is equal to 9 centimeters. So that process is really good, and I know you probably already knew that answer, and that's going to be the issue with most of these examples where you could figure it out on your own, but our goal is to understand this process so when you get to problems that aren't quite so simple, you'll know what to do. So we're going to practice this skill a couple times. We're going to isolate this variable by doing the opposite. We're going to divide all of this by 3, which leaves me with x. And I'm going to divide all this by 3 because of the property of equality, which leaves me with 7. You're going to note how important it is to use the division bar, or the fraction bar to show division, to show this work nice and neat. Allows me to cancel it out in that manner. The solution I came up with is 7, so let me check and see if 3 times 7 equals 21. It does, which means this is correct. Another simple example here, I'm isolating my variable by dividing by 5, canceling that out, leaving myself with just x. Because I divided this side of the equation by 5, I'm going to divide all of this by 5. 40 divided by 5 is 8, and so my solution is x equals 8. To prove it, I'm going to multiply 5 times 8. That does indeed equal 40, and so I know that my answer is correct. Now, a division equation, again, we want to write it in this format because it makes it easier for me to set up my cancellations. This shows x divided by 8 equals 3. If I want that x by itself, I need to multiply all of this times 8. And this is the way I'll set that up. 8 times x divided by 8. This is not 8 times 8. That would equal 64. I'm doing 8 times all of this. And 8 times x divided by 8 cancels out, leaving me with just x. And because I multiplied this side of the equation by 8, I'm going to multiply this side of the equation by 8, and x equals 24. If I want to check my work, I'm going to go ahead and plug in those values, and sure enough, 24 divided by 8 does equal 3. I'd like to point out that in division equations, some people accidentally may do the wrong operation. If you do this final step to check your work, you'll know for sure you're correct, or if you've got to go back to the drawing board. In this example, x divided by 3 equals 5. I'm going to multiply all of this by 3 to leave me with x, and then I'm going to do the same thing over here, applying my property of equality, giving me an answer of x equals 15. If I plug in the value, 15 over 3 does indeed equal 5, which means this is correct. So I've got some more multiplication problems, and these ones are a little bit bigger numbers. Makes them a little bit harder because maybe you wouldn't know the answer instantly, and it's a good example to try. If you're ready to try these on your own, you may want to pause the video, try these two examples, and then see how you do. What I'll do is I'll isolate my variable, leaving myself with just x, because the opposite of multiplication is division. I'll do the same thing here. Now, if you don't know the answer to 256 divided by 4, then off to the side, now is the time to show your work down here. But this is not algebraic work, so it should be separate. All right, and so I found the answer is x equals 64. And again, this is a situation where I have an answer of 4 times 64 equals 256. Assuming I divided right, I know I'm right. But because it's possible I may have made a mistake, this would be a great time to show my work and double check. And look at that, it is correct, proving my answer. Here I'm going to divide this by 3 to isolate my variable, leaving me with x. Here I'm going to divide this by 3, and 51 divided by 3 is 17. I know that from just practicing. But just to double check my own work, I'm going to plug this in. And 17 times 3 what am I doing here? 3 times 1 plus 2 is 51. Trying to jump ahead on myself there. And sure enough, that does mean that x equals 17. So with these two regular examples, again, these are division equations, but a lot of people, because 2 goes into 12, will try to tell you the answer to this is 6. And I assure you it's not. We're going to follow our same procedure. This is division, so I'm multiplying by 2 to isolate my variable. I'm also multiplying by 2 over here, getting an answer of 24. If you don't plug in your solution, you run the risk of not having the correct answer. This is indeed correct. Now I'm going to try this one and multiply by 5 to isolate my variable. Multiply by 5, get an answer of x equals 100. Plug in my answer, and sure enough, that's a true statement, and there I go. Now I have 2 word problems we're going to try, and it's really important for you to understand that the most important part of this word problem is it wants you to write and solve an equation. And that's how you're going to answer this question. This is not a hard word problem. Everybody probably knows in order to solve this, $70, with $2 for each item, you would clearly divide 70 divided by 2. But our goal is to take word problems we don't know how to solve and write them as equations. So even though this is a simple equation or a simple word problem, we still want to go through the work. A lot of people would try to write their answer as 70 divided by 2 equals. That's an expression, not an equation. So our goal is to find an equation that will prove this. So let's read this question. You earn $2 for every item you sell for the band fundraiser. Write and solve an equation to find the number of items you have to sell to earn $70. So you know you earn $2 for every item you sell. The number of items that you need to sell is what you don't know. So we want to multiply 2 times the number of items you need to sell to find out what that is to equal 70. That's my equation. $2 times the number of items I sell will equal 70. That's an equation. I can divide this by 2 to leave me with just x, divide this by 2 to give me an answer of 35, and there's my solution. X equals 35. I know that it's true because 2 times 35 does equal 70. So great job on that. The last question we have, there are 52 cards in a deck of playing cards. Write and solve an equation to find the number of cards in 5 decks. Now again, this is a simple question. Most people would know instantly to do 5 times 52, but that's not an equation. That's an expression. So what we need to know is how many cards are there in all 5 decks. So that's our unknown. Now we can do this problem in 2 separate ways. We could do the total number of cards divided by 52 equals 5. So the number of cards divided by 52 equals 5. Or we could do the total number of cards divided by 5 equals 52. It doesn't really matter which way we set it up because both will give us the same answer because of the fact family that we're working with. I'm going to choose to do this one because I'd much rather multiply by 5 than 52. So I'm going to multiply this by 5, which leaves me with C. Multiply this by 5. I'm going to show that work off to the side. I get an answer of 260 cards in 5 decks of cards. Now I can plug that in. 260 divided by 5 equals 52. And sure enough, if I try that out, 260 divided by 5, I get my 52. And so, indeed, the number of cards in 5 decks is 260. Thank you for sticking around till the end. Good luck with your homework.